and welcome to the lesson number 4, which is quantitative analysis in pharmaceutical sciences. Now in this video we are going to learn about what quantitative analysis is and how you are going to use it for the analysis of different samples. So without making further delay, let us move into the topic. Lesson number 4, quantitative analysis in pharmaceutical chemistry. So dear students, today we are going to study about the quantitative analysis. Broadly, pharmaceutical analysis is divided into, or you can divide this pharmaceutical analysis into two categories. One is quantitative and other one is qualitative. Qualitative deals with about something which is present or absent in the sample, and quantitative analysis deals with the amount of something which is present in the sample. Now let us see the overview. Now quantitative analysis is the determination of the amount or concentration of a substance in the sample. That means you know that the substance is present in the sample, you know it very well, but you are interested in knowing the amount of that sample of that substance into the sample. So you will perform qualitative analysis. Now in pharmaceutical chemistry, accurate quantification is very essential. Quantitative analysis is extremely important because most of the time you want to know the amount of certain substance in the sample. And why do you want to know that? We want to know because we want to ensure the drug potency, the drug safety and the efficacy. Let us say that there is a tablet, is a pharmaceutical formulation tablet in which there is a drug, say this is paracetamol, and this has to be 500 milligram in the sample. Now when you will be performing quantitative analysis, you will check whether paracetamol is 500 mg or not. You know that paracetamol is present in the sample, but you don't know the amount of paracetamol in the tablet. Now when you are performing qualitative and quantitative analysis, you will come to know that how much amount of PCM is present in the tablet. So if it is more than 500, obviously the drug will show its toxic effect, and if it is less than 500, if our amount of PCM is less than 500 mg in this tablet, so obviously there will be concern with the efficacy of the tablet. So we want to ensure the safety, we want to check the potency of our drug molecule, and we want to see the efficacy. That is why we perform quantitative analysis. Now continuing the importance of quantitative analysis, the same thing is written. It ensures that our pharmaceutical product is in the specified amount which is given, not more than, not less than. Okay. Now it is very important for controlling the quality of the substance. It should be in the perfect quality so as it can be given to the patient. If it does not contain the specified amount of the substance, it either can become, it can produce the adverse effect or the toxic effect, or it may not be an effective drug if it contains the lesser amount of drug in the sample. Also, in order to do the regulatory compliance, we have to check whether our drug molecule is in the sufficient amount or not. Otherwise our drug molecule will not pass through the regulatory bodies. Third thing is formulation development. Formulation development always requires to know, after the formulation has been produced, you want to know the amount of that drug molecule, of that API in the sample. So for that you are performing quantitative analysis, and that is why this quantitative analysis is important. Now what is the principle of quantitative analysis? See, the principle include the accurate measurement of the quantity of the analyte. We just want to know the quantity, or you can say that the amount of our substance in the sample. Second thing, we need to understand that there is a relationship between the measured signal and the concentration of the analyte. This is a very important thing and that I should elaborate you. See, for example, there is an instrument by which, with the help of which we want to know the amount of the drug of the substance in the sample. Most of the time I will be taking the name drug. So we want to know the amount of a drug in the sample, say tablet. So when we are testing our drug in the instrument, there is a signal given by the instrument. This signal is directly proportional to the amount of the drug in the sample. The more the amount of the drug will be, the more the signal we will get. For example, say for example, if the instrument is, let us say if the instrument is a photocolorimeter. Colorimeter works on the principle that if the light, visible light is thrown into the sample will absorb some of the visible light and rest part will be transmitted. Okay. Now, if the concentration of the sample will be high, so obviously the amount of the visible light absorbed will be high and obviously the transmittance will be low. So this will create a varied amount of signal. Say, obviously, if the substance concentration is high, you will get a low transmitted signal. And if the substance concentration is low, sample is low, you will get a high transmitted signal. So the transmitted signal will tell us the amount of the substance in the sample. So this is what the second point says. There is a relationship between the measured signal and the concentration of the analyte, and that should be properly understood, and that is why it is the key principle in quantitative analysis. Third thing is, quantitative analysis is very important, and we are constantly performing the calibration and validation method of our analytical procedure to ensure its precision and the reliability. So 3 points are extremely crucial, extremely important in qualitative analysis, and they are counted as the principle. We must all know it. Now, the classical methods of quantitative analysis. There are classical methods. There are 3 methods which can be considered. Number 1 is gravimetric analysis. In gravimetric analysis, we actually form a precipitate by a chemical reaction. There is a chemical reaction happening, you will get a precipitate, and then this precipitate will convert it into a substance of known composition, and this substance is weighed. The weight of this substance is taken, and then we calculate the amount of analyte present in the sample. Second thing is titrimetric analysis. In titrimetric analysis, we perform a titration. Say, let's say that we are having a strong acid in the burette, and we are having a weak or strong base, you say, in the conical. We will react these two, and there will be an indicator. There will be, after the reaction between strong acid and strong base is completed, indicator will change its color at the end point, and at the end point you will take the burette reading, and by that reading and some physical chemistry calculations, you can easily understand the amount of, you can easily know the amount of base present in the sample. So this is a titrimetric analysis, which is also a kind of quantitative analysis. Now, third thing is volumetric analysis. Volumetric analysis is basically we are indicating those analysis in which we are particularly concerned about the reacting volumes of the substance. We are concerned about the reacting volumes of the substance. The above said titrimetric analysis is also a kind of volumetric analysis. So these three are the classical methods of analysis. Now in the modern days we are having modern instrumental method of quantitative analysis. So the modern instrumental techniques include first HPLC, high performance liquid chromatography. It is a kind of chromatography which is very sophisticated, very fast and very accurate technique. It is used to separate the component in a liquid mixture. You not only separate the components in the liquid mixture but also you quantify those substances. The second thing is gas chromatography. Gas chromatography is basically concerned with the volatile compounds. So there will be a mixture of volatile compounds in the liquid sample. You will separate those volatile compounds and for that you need gas chromatography. Now third method, which is a modern method, it is spectrophotometry. It will check the absorption of light to determine the concentration. There will be a sample. You will throw some kind of light like ultraviolet, visible light into it, UV light or visible light into it. The sample will absorb some of the light and rest of the light will be transmitted. And by that absorption, you will know the amount of the substance present in the sample. As I have already told that the more substance present in the sample, the more amount of UV light will be absorbed. Now, last technique is this is mass spectrometry. Mass spectrometry is basically used to determine the molecular weight of the organic compounds. It determines the mass and the structure of compound and it can also be used for the quantitative analysis. Now what are the selection criteria for the quantitative analysis? Now first thing is nature of the sample. The nature of the sample will depend on how or what kind of quantitative analysis you are going to do. For example, there is a pharmaceutical tablet and it contains multiple active ingredients. There are say 2 drugs in the sample. So you can use HPLC or GC. It will separate these two components and it will also tell the relative amount of these components into it. So that depends. Nature of the sample will tell us what kind of chromatography or what kind of procedure quantitative procedure are we choosing. Second thing is sensitivity and precision requirement. Say if we want a very highly sensitive instrument and we want additional information, like for example there are two components in a sample. We not only want to separate them but we also want to identify them through their molecular weight. Then we are using HPLC MS. HPLC, high performance liquid chromatography combined with mass spectrometry. These two methods will do the thing for us. HPLC will separate the instrument, it will separate the sample. It will also quantify them, the amount of them components present in the sample, and mass will tell us the molecular weight of each of the sample, and mass spectrometry will help us to identify those sample as well. Now next selection criteria is the availability of the instruments. For example, you are having both HPLC and GC, right? You are having HPLC in your lab as well as you are having GC in your lab. There is a sample which have the volatile compounds. You want to separate them and you want to identify them. So obviously you will use GC because GC is specifically for the volatile compounds. Some instruments are specific for some kind of compounds. So that depends upon what kind of instrument you are having, what kind of sample you are having. Now cost and time consideration. Say if there is a time consideration, you want to separate some component, like for example you are having HPLC as an option, you are having column chromatography as an option. So you want to separate your component very fast. So if you have time constraints, you want to do it very fast, you want to separate them fast and get the results. So you will be taking or you will be applying HPLC. Column will also do the thing, but column, the problem with column is that there will be a lot of time consumed, and also column will, after taking the column, you have to manually check the amount of each component in the sample, whereas HPLC will give everything recorded in the computer. So, but as per cost consideration, HPLC is not cheap. It is a costlier technique than column. So it depends upon what kind of consideration you are having. Are you considering time or you considering the cost? So if you are considering time, then go for HPLC. If you are considering cost, then you should go for column. So it's a very simple example. Now there is another example written in our slide. Like we are doing a rapid analysis like UV visible spectroscopy. You can choose this method for the routine testing. So there are other methods, like you can also use colorimetry, photocolorimeter. But colorimeter will take much time and UV visible spectroscopy will take lesser time. So if you want that your analysis should be done in a lesser time, then you will definitely go for UV visible spectroscopy. Now, considerations in quantitative analysis. So there are some important things that you need to consider. Like first thing is calibration curves and standard solution. What a calibration curve is? Say you are having a standard solution. In the previous class I have already told you that standard solutions are those whose concentration is known to you. Now you know the concentration of this standard solution. Now what you are going to do is that you will take these samples and you will test them in your, say, your HPLC instrument, and there is a curve that you will form. Say in the x-axis you will be having the curve of concentration, and y-axis you will be having the amount of the sample. So not amount, you will be having the area under the curve, like that. And now with the standard help of standard solution, you know the concentration of the solution, and then you know the signal, and for with the help of this you will draw a graph. You know the concentration because this is your standard solution, and you know the AUC because you are doing it in your HPLC. Now you draw a graph. Now for example, if there is an unknown solution that comes around, so you check that AUC, RF value, and you can also check the concentration by extrapolating or by dropping the perpendicular to the graph. For a particular kind of signal, you can understand that what would be the particular kind of concentration. So by the help of this thing, you can easily, by the help of calibration curve, you can easily understand, you can easily know the amount of or the concentration of the unknown samples in the solution. Now, quality assurance and validation protocols, it's very important. See, when you are using a new analytical method, you must ensure yourself that your analytical method is accurate, precise, and it is extremely reliable. So what you will do is you will do the above thing that I just have just told. You will analyze your method with the standard sample, the samples whose concentrations are known, and you will analyze them under various conditions. And if the results are same, and then you will easily know that your method is validated. Now, compliance with the regulatory standards and guidelines, it's very important that regulatory agencies like FDA, they require pharmaceutical companies that they should stick to the specific analytical method for drug testing. This is all given in the pharmacopoeias. So if you are testing any drug, you cannot choose it by yourself. You cannot choose the method by yourself. You have to choose the method for that particular drug which is given in the monograph of that drug. So that is why you will comply, that is how you will comply the regulatory guidelines. Now, summary. So qualitative analysis is very important for pharmaceutical chemistry, as you know, and you can quantitative analysis is required, and quantitative analysis is used to determine the concentration of the analyte. There, the principles of quantitative analysis, they include accurate measurements, a calibration and validation. There are classical methods like gravimetry, titrimetry, and volumetry, and there are modern instrumental methods like HPLC, GC, and spectrophotometry, because these modern instruments are time saving, they are precise, they are efficient, although they might be not be cost effective, but they are accurate and reliable instruments. Thank you. So, dear students, I hope you have understood the pharmaceutical analysis in the quantitative aspect. Now, in this chapter, you have learned about different instruments, different ways of doing quantitative analysis. So, as there is a quantitative analysis that you have already learned, there is also qualitative analysis. So, in the next chapter, that is your lesson number 5, we are going to study what qualitative analysis is and the same different aspects as we have studied in this chapter. So, till then, we will meet on the next video. Till then, goodbye.